Alright, here we go with the Pythagorean Theorem, and we're going to start off with a little warm-up here, getting you guys to understand. Again, we're going to be simplifying roots here. So if I want to square root 144, we probably all know that the answer to that is 12, because 12 times 12 is 144. But if I want to square root 75, there's no number of times itself that equals 75. My screen's going a little wonky here, sorry about that. So I'm going to do this the way I showed in class a while back. I'm going to use what I call a factor branch. So I'm going to take my 75 and I'm going to prime factor this. So what I want to do is I want to divide the smallest prime number that I can get into 75. Not sure what's going on with my screen here today, sorry about that. So I'm going to divide 75 by 3. 2 doesn't go in, so I'm going to start with 3. 75 divided by 3 is 25. And then I would do the same thing again. 25 divided by 2 doesn't work, 3 doesn't work, so I go to 5. 25 divided by 5 is 5. And then again, I keep going until I get 1 on the left side. Anytime I have a pair of numbers that are the same, think about 5 times 5. This is the square root of, if you multiply those back, that would be the square root of 25, which we know is equal to 5. All right? The 3 does not have another number to pair up with, so it's going to go back inside the square root, and my answer would be 5 square root 3. All right? I do the same thing with 72 over here on the right. I'm going to start off with 72. I'm going to use my factor branch here. I'm going to start by dividing by 2. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 doesn't divide by 2, so I go to 3. 9 divided by 3 is 3. And 3 divided by 3 is 1. So you can see here I've got a pair of 3's. Again, imagine multiplying those together and putting them back in the square root. That would be the square root of 9, which we all know is equal to 3. Same thing with the 2's here. If you multiply those back together, that's 4. Square root of 4, that equals 2. And the 2 up on top doesn't have anybody to partner up with, so it goes back inside. If you multiply all 3 of these numbers together, you get 3 times 2, which is 6. And then the square root of 2. Okay? So that's one way to simplify square roots. Not the only way, but one of the ways to do that. All right, so today we're talking about Pythagorean Theorem, and basically the Pythagorean Theorem says that if A and B are the legs of a right triangle, so I'm going to label my right triangle over here, A and B are the legs, C is the hypotenuse, then the Pythagorean Theorem states that A squared plus B squared is equal to C squared. Okay, so example number 1 says find the missing side. So I've got 2 sides here. These are the legs. Okay, another way to look at the Pythagorean theorem, which I usually state also, is leg squared plus leg squared equals hypotenuse squared. Okay, kind of makes a little more sense once in a while. So when I look at this first triangle here, I see leg, and I see the hypotenuse is missing. So I'm just going to let this first leg equal A and this second leg equal B. If you're thinking about it as A squared plus B squared. So I have 8 squared plus 15 squared equals C squared. I cannot square root first here. Okay? You cannot do this because square rooting over addition does not work nicely. So we don't want to do that. What we want to do is we want to solve the left-hand side. And so we'll go back and do that. That's 64 plus 225 equals C squared. If I add these guys together, that's going to be 289 equal to C squared. And if you pop out your calculator and square root both sides of this, okay, so I'll show that little step. If I square root here and here, normally when we square root, we would put a plus and a minus with the root. However, in this case, we're not going to do that because the side of a triangle has to be just a positive root. And I believe this turns out to be 17 for C. Now, I would encourage you at different points in the video to turn off the video, try the examples on your own. I think it'll make things a lot easier to understand as you go through and work some of these examples, and it'll ultimately help you out in the long run here. So I'm going to let you try that if you want to. Okay, so this time I've got leg squared of 5, so I'm going to let that equal A. And my B leg is missing, and C is going to be the 10 over here. So we've got 5 squared plus B squared equals 10 squared. 5 squared is 25 plus B squared equals 100. If you subtract 25 off of both sides, you get B squared equals 75. And we did 75 up in the warm-up, so we know that this is going to equal 5 square root 3. Okay? That was pretty easy, wasn't it? Alright, so our next one here says an isosceles triangle has congruent sides of 20 centimeters. So isosceles means that you have two sides the same. So let's see what we got here. I'm going to draw a little isosceles triangle. Alright, here's my two sides that are the same. This is 20 and 20. It says the base of the triangle is 10 centimeters. And the question states, what is the area of the triangle? So area of a triangle, if we're thinking about right, or just plain old area, area is 1/2 base times height. Now I've got a base in this triangle, but I don't have a height. My height would technically be this line straight up and down right here. Okay, so I'm going to call that H. And the nice thing is, because this is an isosceles triangle, if I draw that height straight down the middle, it splits the bottom piece directly in half. Now that wouldn't typically happen in a normal triangle, but because it's isosceles, I can split that. And so what I end up with here, I'm actually going to draw another picture down below. What I end up with is this picture right here. So if you just look at the right side of this, I have a leg of 5, a hypotenuse of 20, and my height over here, we'll call that H. So if I look at this, these are right triangles here. If I look at just this piece of this, all I need to do is figure out how to plug this into the Pythagorean Theorem to solve for H. So I'm going to do H squared plus 5 squared equals 20 squared. This is H squared plus 25 equals 400. If we subtract 25 on both sides, I get H squared equals 375. And I'm going to assume that there's no calculator here, so I'm going to square root both sides here. Okay. So I need to break down the square root of 375. So I'm going to need a little bit of room for this maybe, so I'm going to come up here to the top, just like we did in the warm-up, and I'm going to start to break down 375. Now, I don't know if 3 goes into here or not, maybe without a calculator, maybe you can figure it out in your head. 2 obviously doesn't go in, so I'm going to start with 3 up here. 375 divided by 3 is going to be 125. I don't think 3 goes into there, so I'm going to go with 5. 5 goes 125 25 times. But you can also divide that by 5, which is 5. You can divide 5 by 5, which is 1. That's how I know I'm done. Now I've only got a single pair of 5s that can match up over here. Remember, 5 times 5 is 25. That's a perfect square. So those two 5s get to come out of the root. The 3 and the 5 have to go back in the root. They don't have anybody to pair up with, and that's going to be 15. So H is actually going to be 5 square root 15. Now that I know H, I can come back up to my formula, and I can do A equals 1/2 times the base. Now don't use the base on the purple triangle over here. Use the base on the original triangle. That's 10. and the height, which is 5 square root 15. So if you multiply all this together, you get area equals half of 10 is 5, and 5 times 5 root 15 is going to be 25 square root 15. And since this is area, this would be some sort of units squared. Oh, they talked about centimeters at the top here. So this would be centimeters squared. Okay? That was pretty easy, wasn't it? All right. Hey, look at that. There's your first assignment right there. You guys have fun with that.